bowling ball bracket. So this is actually the video lecture for inertia and mass, but we learned it through the bowling ball bracket. Your warm-up was a flashback to kinematics. These were two test questions that a lot of people missed. So we're going to cover it again briefly. You can have a constant speed if your acceleration is not zero. You can maintain the magnitude of your speed, but turn, and you have accelerated, but still have a constant speed. However, if your acceleration is not zero, either the magnitude or the direction, or possibly both, all right, of your velocity have changed. Therefore, it is not a constant velocity. The reason this is different is that speed is a scalar. It doesn't depend on the direction. Okay, today's activity was an obstacle course for the bowling ball. You also then tried the same course with the soccer ball. After class, we talked about when you had to use the meter sticks to guide the bowling ball. Most people said at the turn, starting, stopping, especially that 90-degree turn. And when you couldn't touch it, it went straight, whichever way you had pushed it right before. Now, when I say easier here, I don't necessarily mean skill-wise, because the soccer ball is not perfectly round, and it was a lot more responsive to when you use the meter sticks. So it required a lighter touch. Why was that? Well, the only big difference between the two items is the mass. We'll get to that. Okay. Football team makes 3 first downs in a row and makes it inside the 20-yard line. Go Bryce. Defense calls a timeout. Why? Well, if you're the announcer, you're probably going to say, it's so that they can stop the momentum. When you couldn't touch the bowling ball, it kept going straight. Why? Well, if you had to explain it to someone, you'd probably use the word momentum. Eventually, we're going to get there. All right? But what do both of those things have in common? They have movement. So we're going to take a step back and be a little more general. Okay, you might have heard the word inertia when you were learning Newton's first law, maybe in IPC or in another middle school science class. And the textbook definition is the tendency of an object to maintain its motion. Okay? And this is just a property of anything with matter. Anything that exists has inertia. Okay? And then there's a YouTube video with an egg. You're welcome to go watch it. Okay? Now, inertia is not actually Newton's first law. Okay? It is just this property of things that matter, okay, that want to maintain their motion. So if it's moving, it wants to keep moving. If it's stopped, it wants to stay stopped. Okay? Now, mass was the difference between the soccer ball and the bowling ball. It turns out that mass is the measurement of inertia. This is how we quantify the amount of inertia an object has. So the bowling ball was more resistant to changing its motion. It takes more effort to get it going, and it takes more effort to stop it. That's why it has more mass. It's not the other way around, okay? Things have mass because they have inertia. Things don't have inertia because they have mass. I know that's confusing. All right, so we do this. We give things a number so we can put it on a scale, right? So we use units, and this SI unit for mass is kilograms. We learned about this before. Please remember that this is the only SI unit that has a prefix that is a fundamental unit. If I'm going to write it in an equation, the symbol is an m. That's the variable. So this is the inertial mass we're talking about. Eventually, we'll compare inertial mass to gravitational mass when we deal with forces. They end up being the same number, but they are slightly different concepts. Okay? It's even more properly called rest mass, but because we're not dealing with anything going near the speed of light, so what we're saying we're dealing with non-relativistic speeds, we're just going to call this property mass. And here's where you might get in trouble in this unit. Mass and weight are not the same thing. Weight is a force, okay? Whereas mass is a property of that object, and it quantifies how much inertia that object has. Okay, for your quiz, there is a good video on Veritasium on YouTube explaining the difference between mass and weight. I highly recommend it. Okay, in class, we talked about which one of these has the most inertia. Working backwards, we can't really experience inertia, but we have some sense of what mass each of these items has. The one that has the most mass is the cafeteria. Therefore, out of these 5, it has the most inertia. All right, your homework, by the time you're watching this, the motion post-test is closed. Your reading assignment consists of 3 pages of an article and 3 questions due at the beginning of class Monday. And since you're currently watching the video, from here, go to Moodle and go to Unit 4, Conservation Laws, and take the quiz called Inertia and Mass, due 9 a.m. Monday.